Hey guys, welcome to another video for pre-calculus. In this video we're on 10.5 and what we're doing is we're going to be working with binomial theorem and we're going to be using Pascal's triangle to simplify a binomial expansion form. Working these out without Pascal's triangle can be very long. So what we're going to do is we want to shorten that process. I'm going to show you a shortcut with Pascal's triangle and how to work these binomial problems, because even though there's only two terms, they can be, they can take quite a while to do. So let's stop talking and let's just work some of these out. All right, so problem number one, you see here 2 plus x raised to the fourth power. Now, what I could do is I could do 2 plus x times 2 plus x times 2 plus x times 2 plus x. And then I can go about working this out, the expansion form, but I don't want to do this. This is going to take forever, okay? This is not what we want to do. There is a way to do this where you can shorten your work, and you can use Pascal's triangle. Now to develop Pascal's triangle, the thing that you want to start off with is a triangle of ones, okay? And then you want to get the sum of the first row. So this is going to be my row 0, and then this is my row 1, and then my next row will be row 2, and then 3, 4, 5, and it goes down the line, okay? So keep that in mind. This is row 2 that I'm about to work on, and this top one is row 0. Okay? So to get row number 2, I'm going to get the sum of the two ones, which is 2. Oops, what happened there? Which is 2, and then I will have ones on the outside, right? And so then the sum of these two terms will be 3, and then I have ones on the outside, right? So you'll notice that now I have row 3. So now to work on row 4, I'm going to do 4, 6, 4, 1, 1. I'm going to stop there because the problem is saying that I'm going up to the fourth power. So I'm going to stop at row number 4. So that's how you know when to stop in Pascal's triangle. So what I've just done is going to play a vital role in shortening up my work for this type of problem. All right, so let's go ahead and dive in on this. So one of the ways that you would work this out is, so you're going to have some coefficient, and that coefficient will be determined by this row here, okay? And then you're going to have your a term. Okay, the general formula for this is going to be your n choose r, and I know you don't know what that means just yet, but just stay with me for a second. So that n choose r, this here, that's going to be a coefficient. Okay, that's a coefficient, and this n over r, n choose r, this is showing me how I'm going to end up working that out. Okay, now you may not know that just yet, but we'll get to that. So I will be multiplied by a raised to the n minus r power times b raised to the r power. Okay, and then I'm going to add that to my next term, which will be another coefficient, n choose r, so some coefficient times a, right? Okay, now here, let me actually start to work it out so you can kind of see what's going to happen here. All right, so I'm going to have some coefficient, right? I mentioned that before, n choose r. And then my a is my 2, right? This is my a term. And this is my b term. And then this will be my n term. So that n term, here I'm doing it in green. That n term is going to be this one right here. Okay? So it's going to be 2 raised to the n minus r. And in this case, it's going to be, my first term is, my n is always 4, and at this point right now, my second term will be 0. So these numbers here will represent my exponents. So a to the fourth power times my b term, which is x raised to the 0 power. Yes? Okay, so that's my first term. All right, so then I'm going to add that to my second term, which will be some coefficient, which now it's still going to be 4. And then my second term, or my second exponent, will be 1. So it's going to be 4 choose 1 times my a term raised to the now third power times my b term, which is x, now raised to the 1 power. Okay? Plus, again, some exponent. Let me do that again. So some exponent, 4 choose 2. So that's a to the second power times x, my b term, to the second power. Now notice what's happening to my a term. I want to highlight my a term in green and look at the exponents. Each exponent, at each term, my exponent is going down 1. And now look at my b term and its exponent. That exponent is going up 1, right? Okay, so that's just an important pattern to take notice of. And then finally, my last term, let's see, let me make some space here. My last term will be some coefficient, 4 choose 3 times a to the first power times x to the third power. Now also notice how my exponents, they all add up to whatever my n was, which is 4. See, when I add all these up, that's 4, this is 4, and that's 4, right? So take notice of that pattern. Okay, so finally then I will have my last one, which will be plus some exponent, 4 choose 4, and that's how I know I'm done. That's my last one, is when my top number and my bottom number are the same. So my a term, my a term, which is 2, now it's raised to the 0 power, and my b term, which is x, is now raised to the 4th power, right? Still equals 4. Okay, so one thing I want you to focus on right now, I'm going to highlight this in pink. Oh, that wasn't a good one for that. How about I highlight it in blue? Would that be better? Barely. Let's try a different color. How about orange? This will be my last. Let's just do yellow. Okay, yellow works. Seems to be the golden color for these. Okay, so I've highlighted my coefficients. Now, before I show you the long way to do this, and this notation is the long way. This is binomial theorem. But before I show you the long way, let me show you a shortcut. Now, let me take you back to what I did earlier with Pascal's triangle. This is where Pascal's triangle is really important, and it helps us out a lot, is that you'll notice my Pascal's triangle, I have a 1, 4, 6, 4, 1. Now, what I can do, what this does for me, and this works with binomials, only binomials, is that instead of using my notation of 4 choose 0, 4 choose 1, and I'll show you how to use that, 4 choose 2, 4 choose 3, and 4 choose 4, what I can do is, the shortcut is that I can use what I did here with Pascal's triangle. I can use those numbers as my coefficients. Those numbers actually represent my coefficients. So a coefficient of 1 here, 4, 6, 4, and 1. Isn't that cool? So I have my coefficients. Now it's just a matter of simplifying my problem. So I have a coefficient of 1, and then 2 to the 4th power times x to the 0 power, which is just 1, right? And 2 to the 4th power is what? 16? 2 times 2 is 4, 8, 16. So that's 16 plus, and then over here, I have plus 4 times 2 to the 3rd power times 2 to the 3rd times x. X to the first is just x. So this is what? 8 times 4 is 32x, right? And then my next term, here, let me go with the colors that I chose there. My next term is going to be my 6 coefficient times 2 to the 2nd is times 4 times x squared. That's 24x squared. And then my next term is plus coefficient of 4 times 2 times x cubed, that's 8x cubed, and then finally plus, I have a coefficient of 1 times 2 to the 0 is 1 times x to the 4th is x to the 4th. And there it is. There is my expanded polynomial using Pascal's triangle. Okay? And that's Pascal's triangle is applied in this way where it's an easy way to find my coefficients, and then from there it's just a matter of simplifying the problem. Okay? So now that I've shown you how Pascal's triangle works, let me just go ahead and work it out the long way using binomial theorem. So this is where the 4 choose 0 comes into play. All right, so binomial theorem, here is the general form of it, is equals, so C, n choose R, so that would be C, my n, if you recall, my n is the 4, and then my R is the bottom number, so in this case it would be n choose 4 choose 0. And the general form for that is, to find the value of what this coefficient, this is the coefficient, binomial theorem, is the factorial of n over the n minus r factorial times the factorial of r. All right, so what does that mean? A lot of fancy words, a lot of fancy notation. It's not that complicated really when you break it down. Okay, don't you hate when people say that? But hopefully after you're working out a couple of these, you'll find that it's really not too bad. But in any case, so I have 4 choose 0. So n is my 4, right? So this is my 4, this is my n, that's my r. So my n is 4, so the factorial of 4 divided by 4 minus 0, n minus r is 4. So 4 factorial times 0 factorial. So what does that exclamation mark, that factorial number mean, or symbol mean? So all that means is I do 4 times 3 times 2 times 1. So it basically multiplies by going down 1 each time. So it's the same thing here, 4 times 3 times 2 times 1, and then 0 factorial is just 1. So now what do I end up with here? That's 12 times 2, that's 24 over 24, that's 1. Right? Well, I already knew that was 1 because I did the shortcut, right? Remember that? All right, so let's work out another one so you can see it play out again. So let's work out with the bottom one. So this is 4 choose 1. So that means this is 4 factorial. And then n minus r is 3 minus 1. So that's 3 factorial times 1 factorial. Okay? And I made a mistake here. 0 factorial is just, it's nothing. It's not 1. It's nothing. 1 factorial is 1 because that's basically, yeah, that's just 1. That's nothing. So all right. So 4 factorial is 4 times 3 times 2 times 1. Now with my top number, I can actually stop right here at 3 factorial. The reason why I'm stopping at 3 factorial is because the bottom is 3 factorial times 1 factorial. And the 3 factorial can cancel out with that 3 factorial, leaving me with 4 over 1. That makes sense? So instead of going 3 times 2 times 1, well, I don't have to keep writing all that out. I know that this is going to be 3 factorial, so I just stopped at this point because I saw that there's a 3 factorial there. See, likewise up here, I could have just said, oh, 4 factorial over 4 factorial. That's just 1. I just didn't do that because I just wanted to do it the long way so you could see how that works out. So this is 4. And again, I already knew that because this is 4. So let's do one more so you can see how this works out with the green. So I have 4 choose 2. So my n is 4. 4 factorial over n minus r. So that's 4 minus 2. That's 2 factorial times 2 factorial. All right, so let's break this down. 4 times 3 times 2. I'm going to stop there at 2 factorial. Reason being is because I see in the denominator I have a 2 factorial. So this one can cancel out with that one, leaving me with 4 times 3 over 2 factorial, which is 2 times 1. So that's 12 divided by 2 is 6. And lo and behold, 6 again. Isn't that cool? All right, so I think with this video, I might just stop at this problem because it's pretty long. Perhaps I'll make another video working out, which other one did I say I would do? I think I said number 3. So I'll work out another one with number 3, and I'll work out number 3. Let me write number 3 down for you so you can see what that looks like. So number 3 in the book is 4a minus b cubed, okay? And I'll work this one out in another video because this b term here, you know, there's a common mistake made with a problem like this, which I'll address in the next video. But in any case, I hope that you could see here how binomial theorem, which is this, can work out. When you work it out the long way, you end up getting the same thing when you work it out using Pascal's triangle. Okay, so the goal of binomial theorem, okay, is to find the coefficients in these terms. So by using Pascal's triangle, you achieve the same goal. So, it's good to know binomial theorem, but at the same time, it's also good to know Pascal's triangle because it's a shortcut. Okay, so I'm going to stop it here. Thanks for watching, guys, and good luck on your studying.